Welcome back, guys. Today we will start our series with the very basic coding example using arrays. Each day we will try to increase the difficulty level of the questions. So, today we will start with the very basic and easy lead code problem, that is remove duplicates from the sorted array. So, to code this question, first we have to understand what we have given and what we have to output. So here, if we see this example, we are given an array which is sorted and we have to remove the duplicate elements. So by removing, they want we need to return the length of the array which is after removing the elements. That is, for example, this is 1, 1 and 2. So if we remove the duplicates, it should be 1, 2, as 1 is the duplicate one and the length will be 2, right? So before we start coding, let's understand how we can approach this solution. Given an array which is sorted and it contains the duplicate elements and we have to remove the duplicate elements from it. Correct. So whenever we have to remove duplicate elements or we need to make our array unique, the most obvious thing we should always think of is hash tables. Okay, so what does a hash table mean? Hash table is basically we put our elements and the occurrences of those elements, right? So in this problem also we can create a hash table, right, and insert those elements inside it. So we start from our first index, right, and see if one exists in this hash table. As this is empty, we can simply insert 1. Now going to the second element and check if this exists inside a hash table. That is yes, that means 1 is present already in the hash table, that is 1 is equal to 1, that means it already exists in a hash table and we can ignore this element and move to the next element. Now the next element is 2, right? Again we will check if this 2 exists in our hash table, that is comparing it with the top element of the hash table which is 1. It means 2 is not equal to 1, so we will push this 2 inside our hash table. Now coming to the next element which is again 2, what we can do is again the same thing, checking this 2 with the top of the hash table, that is which is again 2, right? That means 2 already exists in the hash table and we can ignore this element, right? Again we have 2 inside our array and we can check this 2 with this 2 of the hash table and we can see that 2 is already present in the hash table, so we can ignore this element as well, right? Now the next element is 3, so we will compare this 3 with the top element of the hash table which is 2, that is they are not equal, so we can push this 3 inside our hash table. As we can see that this hash table now contains all the unique elements, that is we got our answer, that is 1, 2 and 3, and considering the space and time complexity, we can see that as we are looping through this array which is given to us and assume that it is of length n, so the time complexity should be of n, and as we have used extra space, right, for the hashing purpose, the space is of n. Now as we have given this solution, but this is not the most optimal solution as we are using extra space and time also, so we can think of optimizing it further, right? Now in terms of space, let's think how to optimize this. To optimize it further, we can start by checking each element with its surrounding element. We can do so because the array is sorted, so all the duplicate elements will be accumulated at one place. So to check the current element and the surrounding element, we can clearly see we need two pointers. So that one pointer will be at the current element and the next pointer will be at the surrounding element. Correct? So we can start by initializing our two pointers. The first one is I and second one, let's say, is j, and j we initialize at index 1 and I we initialize with index 0. Now in this algorithm we will have two options. First one is either the two elements are equal or not equal, right? If they are equal, that means they are duplicate and we can ignore the element and move to the next element, right? So let's start. In the first iteration, we have 1 equal to 1, right? That means they are duplicate of each other and simply we can ignore this 1, right? As we already have 1 with us. Now move our pointer to index 2. Now for the second iteration, our I is still at 1 and j is pointing towards 2, as now we can see these are not equal, right? That means we have found a unique element, right? So what we can do is we can simply increase our I pointer by 1, and we can, instead of this one, we can simply place a 2 because this one is of no use to us, and we can simply place a 2 here now, right? As now we can move our j to the next element, right? That is j again is pointing to 2. Now our array of I and array of j are pointing to 2. That means they are duplicate of each other. That means we can ignore this 2 as well. See, we are ignoring the elements because we know we have already taken the previous element with us, so we can ignore the further 2's which we will get, right? So again we will point to the next point element, which is again 2, and if we compare this 2 and again this 2, they are equal. That means we can simply ignore this 2 as well and move our j further. Now in this array of I and array of j, we can see that 2 is not equal to 3. That means array of I is not equal to array of j, which means we have found a unique element. Again, what we will do is we will simply do I plus plus, and we can place this 3 to this new ith position. Now our I is here, right? And we can place 3 over here. Now, if we see carefully, if we start from the starting of our array and if we see to this ith position, we have accumulated all the unique elements at one place, right? So that means if we have to back to our code editor and the approach we discussed, let's start the coding. So we are given this array which is nums, right? So first of all, let's store the length of this variable in a variable named n, and the length will simply be nums dot length, right? Now, as per our approach, we will take our pointer and initialize with it 0, and we will simply loop through this array, and the next pointer we will take is j, and it will start from 1, and we will loop through till the end of this array, right? So as we discussed, if the current element and the next element are not equal, that means we have found the unique element. We need to simply increase the ith pointer, and in at ith place we can simply insert our jth element, right? And by end of this iteration, the variable I will contain the length of the array. As we start from the 0 base index, so the length should be I plus 1. Let's start running this and see if it passes or no. So basic test cases have passed, case 1 and case 2, and let's now submit it. Let's wait if, see, it is accepted in JavaScript we are doing, and it is just simply an easy problem. If you go back through our video, you will definitely be able to understand it. So that's it now for this video. If you have any problems or any doubts regarding this, just mention below in the comment section.